Today we're going to look at calculating percents, but I just wanted to discuss a little bit about what the next week is going to look like. This week we cover calculating percents. We're going to do some problem solving using calculating percents. We're going to look at sales tax, discounts, commissions, and then we're going to look at simple interest at the beginning of next week. Once we get this little grouping of lessons done, we can really slow down in math. We were going to have covered most of the concepts we need. So instead of concept, what I'm going to do starting next week after the long weekend is it's going to be concept, practice. And I still think we're going to finish ahead of schedule, and that will give us an opportunity to do some review and kind of look back over the year at the concepts that we've covered and make sure that we all have a basic understanding of what we've done. During that review time, it will be great for you to have your math rule book out so that you can make any extra notes to it or refer to it whenever you're kind of looking back on problems that we've already covered. So today's concept is not that difficult. The last part is probably the trickiest. This beginning part you've done 1,000 times. So part 1 of 3 is a gimme. So as I said, it's a review. If I have a fraction of 3/4 and I want to change that to the decimal, remember top divided by bottom will give me the decimal, and then I can put it in a percent. So here's the math. 3 divided by 4 equals 0.75 times 100 gives me 75%. So I have, let me grab a different color here. I have fraction, I have decimal, and I have percent. And I know that all of you guys are fantastic with solving these kinds of problems. So what happens if it's a mixed number? What happens if we want to buy something and then it was on sale and then we go back and we find out it's more money, or that we went to the movies one day and there was so many people in the audience and the next time there was way more people in the audience? How do we figure out those numbers? Well, if it's a mixed number, you remember that's a whole number with a fraction. So I'm going to write that as 1.75 and it's going to equal 175%. Well, how did I do that? Well, first of all, I'm just going to leave that whole number alone. It doesn't matter if this is 1 or 1,000. You can leave that whole number alone because we're just going to put it in front of the decimal place. Whether it's 6, 9, 12, doesn't matter. Just leave it alone. Solve for this portion, which is 3 divided by 4. So I end up with 1, because I put the whole number back in, decimal 75, because I know that 3 divided by 4 as a decimal is decimal 75. And if I want to make that into a percent, I'm still going to multiply by 100. So I have 1.75 times 100, which gives me 175%. So let's say 600 people, again I'll change colors so the example's different. Say 600 people went to a concert on Friday. And the question tells us that 175% more people and I'm going to use that number as a decimal. And I'm going to grab my handy dandy calculator. Remember that you can use a calculator for all of these questions. I'm not testing your multiplication or division skills. So here we go. I'm going to grab my calculator and I'm going to plug in 600 times 1.75. And that gives me an answer of 1,050. So if I went to the movies Friday or a concert on Friday night and there was 600 people there, and on Saturday 175% of that original showed up, that would mean I had 1,050 people attending that concert. Okay, so whatever it is, if it was 280, we would multiply by 2.8. it's going to give us the greater number. And you're going to see this come into effect when we talk about sales tax. A lot of times we've been taught when we look at sales tax, well, it's 7% and it's 8%, so we find 7 and 8 and we add that to the original. But if we always put this 1 in the front, and I'll show you that tomorrow or Wednesday when we're looking at this, if I put this 1 in, this 1 will take into account that original number. So just like here, as soon as I put this 1 here, it told the math sentence that we have the original 600 people, but now we have 75% more as well. So you could do it in 2 steps, but there's no point, because as long as we take into account that original amount, we're good to go. So we have one last thing to look at today. And sorry, I'm just reopening my computer so I have the right example for you. And of course I typed in the wrong password. There we go. All right, so the last part that we want to look at today is what happens if that percent is less than 1? So what happens if now we're dealing with parts of a percent? So if you think about it like a dollar, and a dollar in terms of pennies is our decimal. So let's say we had 89 cents, which would be 0.89 of that dollar. Well, what happens if I'm now talking about a third of a cent? So as a third of a cent, I would be writing it as 0.03. I'm not quite at a full cent yet. So that's what we're looking at right now, which is percents less than 1. And the example I gave in your Google Doc was we had 3 over 2,500. Again, to turn that into a decimal, you all know it should be echoing in your brain by now. 3 top divided by bottom. And top divided by bottom is 0.0012. That's what it looks like as a decimal. If I want to turn it into a percent, I'm going to multiply by 100, which equals 0.112%. That's less than 1%. It's about 1/5 of 1%. So if I had to write this number as a decimal, I had explained to you before that we don't usually write 0.12% over 100. The only time you would do that is to show that it was less than 1. This would be a better fraction, but these fractions are actually equivalent. You don't use this very often though. All right, so I have my percent, and say for example, like I said in the Google Doc, that we're looking at Aboriginal people in Ontario. And our question says that Ontario has 11,410,000 people. Obviously that's an estimate. We know that number would never occur in a population. And it told us that 0.35% are Aboriginal. Now, if you're gonna make a mistake here, chances are you're going to make the mistake that you're just gonna multiply by decimal 3.5. Remember, decimal 3.5 as a percent is 35%. You will have increased the Aboriginal population by 24.65%. That's not what we want. So we want to convert this percent to a decimal. So if I multiplied by 100 to get the percent, I can divide by 100 to get the decimal. So 0.35% divided by 100 will give me a decimal of 0.0035. That's the correct decimal we need to multiply by. So I take my 11,400,000 people and I multiply by 0.0035, and that gives me a total of 39,935 people are Aboriginal. Let's get rid of that P in case it confuses anybody. And I can stop and ask myself if this makes sense. Does it make sense that 0.35%, so 0.0035 as a decimal, times 11 million gives us about 40,000 people? Well, it for sure does, because if this was half, so we had multiplied by 0.5, we'd be at about 6 million people. If it was a quarter, we'd be at about 3 million people. If we keep going down, we can find that 39,935 makes sense in this question. And that's what you have to do sometimes with these problems where you're dealing with the decimal as a percent. So a really, really, really small number. Stop to make sure that your answer makes sense. If I ended up with a really large number here, say I had made a mistake and multiplied by 0.35, I would have ended up with about 4 million people, 3 to 4 million people, somewhere in there. And that tells my brain that can't be right. How can 0.35, so less than 1% of the population, equal 4 million people? So let's try one more. If I have, and I'm just going to make this up, so I'm grabbing my calculator again. If I have 7 over 11,240 as a decimal, top divided by bottom, so top 7 divided by 11,240 equals 0.0006. And I'm going to leave that because my next digit is a 2. So this is it as a decimal. If I wanted to change that to a percent, I'd multiply by 100, which would give me 0.06. That means we have 0.06 of a percent. So about 1/13 of 1%. It's the decimal number I need to use. So let's say the, South African population in Ontario was 0.06%. What I would do this time is 11,410,000 times 0.0006. Now the first thing I'm going to ask myself is 0.06% bigger or smaller than 0.35%? Well, it's smaller. It's about a sixth as small. So my brain should automatically know that this number should go down. The number of South Africans living in Ontario should be less than Aboriginals. So let's see what happens. Again, 11,410,000. And we're going to multiply that by 0.1236. And I get 684.6 people. Yes, my number went down from almost 40,000 to less than 1,000, and that makes perfect sense. So today's math is mostly just dealing with these numbers. You're going to do your normal math, which is top divided by bottom times 100. Your next concept is going to be where it's that mixed number, so 2 3/4. Write that as a percent and a decimal to find your new number. And finally, a little bit of dealing with decimals that are smaller than 1%. Again, if you have any problems when you're doing your math, you can always email me or you can invite me on a Google Hangout. What I've been doing with a lot of people is just pulling up a Google Doc. We meet on the Google Doc and we can type back and forth. So I hope everybody has a fantastic day, and I'll see you tomorrow with calculating problems with percents.